Series connections are created by connecting the negative terminal of one cell to the positive terminal of the next cell, and so on, to increase the overall voltage of the battery pack, while its capacity in amp hour remains the same. For example, I have these 4 identical 18650 cells. Each of them has a voltage of 3.7 volts and a capacity of 2600 milliamp hours. If I connect them in series like this, I'll get a battery pack with a total voltage of 3.7 volts multiplied by 4, which will give me 14.8 volts. And its capacity remains the same, which is 2600 milliamp hour. If one battery fails or is removed, the total voltage will be reduced. The battery pack will not be able to provide the full power to the application. What is a parallel connection? Parallel connections are created by connecting the positive terminal of one battery to the positive terminal of the next battery, and the negative terminal of the one battery is connected to the negative terminal of the next battery. When cells are connected in parallel, their capacity and amp hours will be added to each other. Therefore, it increases the total capacity of the battery pack, while the voltage remains the same. Using the same cells from our earlier example, I'll connect them in parallel this time by joining their positive terminals together and the negative terminals together, like this. We'll get a battery pack with a total capacity of 2600 milliamp hours multiplied by 4, which will give us 10,400 milliamp hour, and its voltage will still be 3.7 volts. If one cell fails or is removed, the total capacity of the battery pack will be reduced instead of the voltage. But the other cells will still be able to provide power, which means the battery pack can still keep your application running, just the runtime will be shorter. What is a combination series and parallel connection? In general, series connections are used to increase the overall voltage of a battery pack, while parallel connections are used to increase the total capacity. And sometimes to achieve both a higher voltage and a higher capacity, the battery pack can be configured in a combination of series and parallel connections. In addition, when creating a battery pack, we typically connect cells in parallel first, then connect them in series since it's more efficient, especially when working with cells which requires protection circuit boards, such as lithium ions. Let's use these cells again for our example. I'll take these two and connect them in parallel. I'll do the same for these two. We'll get 2 groupings of cells in parallel, with each having a capacity of 5200 milliamp hour. And because it's in parallel, their voltage remains the same, which is 3.7 volts. Then I'll connect these 2 groups in series. We'll get a battery pack with a total voltage of 7.4 volts and 5200 milliamp hour. And since I connected them in parallel first, I'll need to use only one PCB for this pack. Knowing about series and parallel connection in battery packs can be useful because it allows you to understand how to create one with a desired voltage and capacity for specific applications. What's more, if you're planning to build your own battery pack, besides knowing the voltage and capacity of the pack, the type of connection to use, you'll need to pay attention to other specifications, such as the charging and discharging rate. Each pack will have a standard charging rate, and the charger's charging current should be aligned close to that rate. If it's set too high, it can put a strain on the batteries and reduce their lifespan. If it's set too low, the battery will still be charging, but it's going to take a long time and may not be suitable for your personal preference. Other specifications to consider include battery chemistry, operating temperature, size, and weight, and its durability. Knowing these specifications will help to determine the performance and suitability of your battery pack for a specific application, so that it can perform optimally and meet the needs of your application. It also goes without saying, when building a battery pack, you'd always want to choose cells that have similar specs to get the best results. That's it for today's video. We hope you've learned something useful. If you have any questions, feel free to leave us a comment. If you need help to build a custom battery pack for your application, feel free to contact us. We're happy to help. Don't forget to like and subscribe to our channel to see more content. Thanks for watching.